All right. Whew, that was a lot of introductory parts. Hopefully, you have a better understanding of how Vault works and the different versions and why organizations choose Vault and all those kind of things. Now, what we're going to do is actually kind of get into the meat and potatoes of Vaults, like the core components that make up a Vault solution. So the first one that we want to talk about is storage backends. The storage backends is where Vault will actually store all of its data in encrypted fashion on Vault. So there are a bunch of different options for storage backends. If you're running enterprise, you're probably running Raft or you're probably running Console as the backend. But if you're running open source, there's a wealth of supported backends that you can use. Now, the other one is secrets engines. So secrets engines are really the heart of everything that Vault does. You are deploying Vault because you want to use secrets engines. You don't want to use storage backends or these other things, like you want to use secrets engines. Secrets engines either store, generate, or encrypt data. So these are the core functionality of Vault that you're after. Now, in order to use these secrets engines, you have to authenticate. So Vault has auth methods and a wealth of different auth methods that you can use to authenticate to Vault to retrieve a token to access secrets engines. And finally, you have audit devices. So because Vault is a security product, we need to make sure that everything happening in Vault is 100% audited. So we have different audit devices that we can use to ensure everything is properly logged. So we're going to take a deep dive into each one of these Vault components to make sure you fully understand it. A lot of these are part of the objectives that we'll talk about soon. I believe even objective one is auth methods, and there's another specific objective for secrets engines. But in this section, we will dive deep into storage backends and audit devices because they are not necessarily part of a specific objective on the exam. So let's talk about storage backends. So storage backend configures the location of the storage of the Vault data. So when you're writing to the KV or you're making any configuration changes in Vault, it stores that on storage backend. Now, this storage is defined in the main Vault configuration file, and each different storage backend has different parameters. So if you're storing things on console, that configuration may look different than if you're storing it in Raft or DynamoDB or somewhere else. So each one has its different parameters. Now, all the data that's stored on the storage backend is encrypted in transit using TLS certificates, and it's also encrypted at rest using AES 256. So everything that's stored is 100% encrypted at rest and in transit. So not all the storage backends are created equal, right? So some of the storage backends support high availability, some don't. And what I mean by that is if you deploy a single Vault node, you can use any backend storage that you want. But if you want to cluster Vault, so you have high availability, you need a storage backend that supports high availability. Now, other storage backends have better tools for management and data protection. So if you think about console has snapshots. If you think about DynamoDB, you can take snapshots or backups of DynamoDB. If you're just storing it in a file somewhere or S3, like you may need to go manually back that up, somewhere else. So different backends have different tools just depending on the backend platform that you're using. Now, I want to be clear here that for each Vault cluster, there's only one storage backend. But on top of that, for every Vault cluster, you will have a backend. So if you're deploying 6 different clusters in your organization, you're going to have 6 different backends. That could be a console cluster. You could be using the integrated storage, which is Raft. You can have 6 different S3 buckets, right? Or something like that. So for each Vault cluster, you're going to have a storage backend, but each individual Vault cluster only points to a single storage backend. And we're going to have more details about that in this section. Now, secrets engines, again, Vault components that are responsible for managing secrets for your organizations. So secrets engines can either store, they can generate, or they can encrypt data. Those are the 3 things that secrets engines can do. Now, a lot of these secrets engines can connect to other services and to generate credentials on demand. So we talked about the dynamic credential or the dynamic credential generation. So a lot of times Vault can connect to a backend database or connect to AWS or GCP or Console or some of these other services to generate credentials against those backend platforms. So Vault obviously needs to make that connectivity between Vault and that backend platform. So many secrets engines can be enabled and used as needed. You can even enable multiple secrets engines of the same type. So if you enable the KV store, you can enable 20 different KV stores as long as the path name is different. And talking about path, all secrets engines and really everything else, auth methods, audit devices, and all that stuff, they are enabled and isolated at a path. And all interactions are done directly with that path itself. And we'll go into more on that in a future section. All right, so let's talk about auth methods here. Now, auth methods are going to be the subject of objective 1 here, but here's a quick breakdown of auth methods. They are exactly what they sound like. They're Vault components that perform authentication and manage identities within Vault, right? So if you have applications or human users that are authenticating to Vault to get access, you would go through an auth method. They're responsible for assigning identity and policies to a user. So we saw earlier that once we are authenticated, we get a token. That token will have a policy associated with it. And that, again, gives us access to certain paths, kind of like our hotel before, where our key card gets us access to certain amenities. Depending on what the hotel gives you, your token will give you access to certain paths. And those are all based upon the policy that's attached to the token. All right, so multiple authentication methods can be enabled depending on your use case. Now, there are different types of auth methods. Auth methods can be differentiated a lot of times between human versus system methods or machine methods. So if you think about username and password or OIDC or things like that that require a human to a lot of times type in credential, a lot of times those are human-based authentication methods where you have things like tokens or app role or TLS or things like that are more geared around machine-to-machine authentication, right, for systems. Now, again, once you're authenticated, Vault will issue a token, and that token will be used to make all subsequent requests. Again, just like our hotel, when we authenticate, we're issued our key card. We use that key card to make all access requests to the gym, to the spa, to our room, all those kind of things. Same thing. Vault will give us a token, and we'll use that token for all future requests. I need access to the secret. I need to go write data here, right? We'll use that token to do that. Now, the fundamental goal of all auth methods is to obtain a token. And that, of course, is you're not using a token directly, right? There's a token secrets engine. So if you given an application just a token directly, it's not going to use a token to get a token, right? But if you're using LDAP, OIDC, app role, any of these, Kubernetes, any of these other auth methods, the fundamental goal of this auth method is to obtain a token. And then again, that token is used to make all requests. Now, each one of those tokens has associated policy or multiple policies, and it has a TTL, right? How long is this token valid for? Now, Vault has one and only one default auth method for a new Vault deployment, and that is tokens. So when you first initialize Vault, and we'll talk about initialization and all that stuff soon, when you first initialize Vault for the first time, you get a root token. That is your only method of authenticating to Vault. And then you can use that to enable additional auth methods. All right, so audit devices. So audit devices, they sound exactly, what they are. They keep detailed log of requests and responses to Vault. So if you have humans or machines or whatever integrating with Vault, audit devices will write those logs for security purposes. Now, audit logs are formatted using JSON, so they're easily parsed to find information in there. Any sensitive information is hashed before it's logged. So you can't go into an audit device log and look for tokens or responses, right? So you're not going to see if I go in and retrieve a secret and that's written to the log, you're not going to see that secret in the log. It's going to be hashed before it's logged. All right, so you can and should have more than one audit device, and this is because Vault prioritizes safety over availability. And what I mean by that is that if you have a single audit device enabled, now by default, there are no audit devices enabled, but you should obviously enable one. If you have a single audit device enabled, Vault requires that at least one audit device to write the log before completing the Vault request. So in other words, that's where it goes back to prioritizes safety over availability. So if Vault cannot write a log or a request, it will not respond to the client. So for example, if you're writing a log to a local file and the hard drive fills up or something like that, and Vault can't write the data, then Vault will not respond to the client because, again, prioritizes safety or security over availability to our users. All right, so we've talked about a lot already. This is going to be a long section, but we still got quite a bit to go. Vault architecture. All right, so let's talk about what Vault architecture looks like. Again, we have our HTTPS, or our API here, and we have users that will integrate directly with Vault, using the API. Now we have a storage backend here, and our storage backend again provides our encrypted storage for Vault. So again, this could be console, it could be stored in memory if you're running like dev mode, it could be stored in DynamoDB, an S3 bucket, it doesn't matter. Vault will store all the data in encrypted form on the storage backend. And finally, we have the core of everything in Vault. So we have the Vault core, we have policy store, audit devices, we have our system backend, our secrets engines, our auth methods. You can see in the middle we have our path routing. And again, we'll talk about that in shortly. But these are all the core components that make up Vault. Now, all these core components in the middle are protected by what's called the barrier. So to get through this cryptographic barrier, you must have a token or you must be authenticated in order to cross this barrier. So anything that moves outside of the barrier is encrypted. You look at the barrier and you look at the storage backend, the storage backend is not within the barrier because Vault inherently does not trust the storage backend because we don't know how your S3 bucket is set up, right? It could be public. You don't know how your DynamoDB is set up or console set up or things like that, right? So we don't trust the storage backend. So before any data leaves the core of Vault and it passes through the barrier, it's encrypted. And any data that comes from the storage backend or the API and moves through the barrier back into the core, it is decrypted so Vault can read it. So again, in order to move through this barrier, you must be authenticated with a token and everything will be encrypted or decrypted as it's passed through this cryptographic barrier here. All right, so Vault paths. We mentioned Vault paths quite a few times already. Everything in Vault is path-based, and that the path is really a prefix, and it tells Vault which component a request should be routed to. So secrets engines, auth methods, audit devices, they're all what's called mounted at a specific path. Sometimes you'll hear these secrets engines or auth methods referred to as a mount. So as you enable different secrets engines or auth methods or other components of Vault, you will have different paths that are available, and those are dependent on the features that are enabled in Vault, such as the different auth methods and secrets engines. So for example, if you enable the AWS secrets engine, it may have additional paths beyond this AWS secrets engines that are available as compared to like a KV secrets engine or something like that. Now the system backend is a default backend in Vault, which is actually mounted at the sys endpoint. So anytime you are writing policies or interacting directly with the backend, you need to enable secrets engines or you need to look at audit devices or things like that. Those are going to be accessed using the sys endpoint. Now, Vault components can be enabled at any path that you like, and you can use that using the path flag. Now, that's assuming you're using the CLI. If you're using something like the UI, it just has a text box where you can type it in. Each component does have a default path that you can use as well. So if you're using the CLI and you don't provide this path flag, it will just enable on a default path. So for example, if you enable the database secrets engine and you don't provide it a path, it's going to mount it at a path called database. Same thing for Azure. If you enable the Azure auth method, and if you don't give it a specific path, it's going to mount it as Azure. Now, Vault does have a few system reserved paths which you cannot use, or you can't remove them either. Auth is the endpoint for interacting with auth method configurations. You have cubbyhole, identity, secret, and sys. Now, secret is only used if you're running in dev mode. So if you're running in a production environment, then you can use secret all day long if you want. But if you're using dev mode, it does enable a KV version 2 secrets engine as mounted as secret here. All right, so how does Vault actually protect my data, right? We're going to be putting a lot of critical stuff in there, and we may have applications that are highly dependent on Vault. So how does Vault actually protect my data to ensure that nobody can come steal my data? They can't read all this stuff. So as we learned, we have a storage backend, and this is where Vault stores all of the data. And we've already learned that it stores all this data in encrypted fashion. But how does it do it? So what Vault does is it generates an encryption key. And this encryption key is used to actually encrypt the data that's stored on the back end. But what we don't want is we don't want to just give somebody this encryption key, right? We don't want to give somebody all the keys to the kingdom here. So what we do is actually we protect the encryption key with what's called the master key. So the encryption key encrypts our data. The master key actually encrypts our encryption key. But again, we don't want to just give out our master key to anybody. So what happens is when we retrieve the master key, we can decrypt the encryption key, and that encryption key is stored in memory. So that allows the Vault nodes to encrypt and decrypt all the data that's stored on the backend storage. So let's talk about these individual keys really quick. So the master key is used to decrypt and encrypt the master key. It's created during Vault initialization or during any rekey operation. So we'll talk about both of those in this course. The master key is never written to storage when we're using traditional unseal mechanisms. So again, we haven't introduced unseal yet. I believe that's the next topic here. But when we're using traditional unseal mechanisms, we never write the master key to storage, and you'll see what we do with it. If we are using auto unseal, the master key is actually written to the backend under core/master on the storage backend. So it's actually stored there, but it's stored in encrypted fashion by using the auto unseal mechanism. And again, we'll go through all that, so don't feel like you need to understand that right now. Now, the encryption key, again, is used to encrypt or decrypt data written to the storage backend. It is encrypted by our master key. It's stored alongside of our data in encrypted fashion, right? Again, it's encrypted with the master key, but it's stored alongside of our data in a key ring on our storage backend. The encryption key could also be easily rotated. So if we have policies internally that say we must rotate encryption keys once a year, every 6 months, or whatever, it's super easy to do that within Vault. And it stores both the old and new keys on the key ring. So we can encrypt new data using the new key, and we can decrypt old data using the old key. All right, so let's talk about seal and unseal, which is a critical subject in Vault. So when Vault actually starts, it starts in what's called a sealed state. And this means that it knows where to access the data. We've given it a file that says, hey, all the data is right here, so it knows where it is. But we don't know how to decrypt it yet because we can't yet decrypt that encryption key. So while Vault is sealed, almost no operations are possible when Vault is in a sealed state. You can only do like a status check, like, hey, are you sealed or unsealed? Or you can go through the process of unsealing. Those are the only operations that are available when Vault is in a sealed state. So in other words, if Vault is in a sealed state, you cannot retrieve data from Vault. Applications cannot retrieve data or generate data or anything like that with Vault. You can't decrypt data, that's been encrypted by Vault. You can't really do anything in Vault while it's sealed. Now, unsealing Vault means that a node can reconstruct our master key in order to decrypt the encryption key and ultimately read our data on the back end. So as we learned before, we reconstruct the master key. We use that master key to decrypt the encryption key. We store that encryption key in memory, and then we use that to read and write data to the back end. So it's encrypted and decrypted. Now, after we unseal, the encryption key again is stored directly in memory, and this is per node. So every single node in the cluster should be unsealed. So sealing Vault basically means that Vault kind of throws away the encryption key. It kind of purges the encryption key out of memory, and it requires another unseal operation to perform any further operations. So Vault will start in a sealed state. Again, you can manually seal it using the UI CLI or API as well. But you may be asking, like, why would I manually seal Vault? Maybe your key shards are inadvertently exposed. We'll talk about that a little bit more. Maybe somebody accidentally committed them to GitHub. Or maybe we had folks that left the organization that were responsible for key shards. Maybe we detected a compromise in our network or network intrusion, and we want to seal Vault to protect the data inside of it, right? So that's another reason we can seal it. Maybe spyware and malware on the Vault nodes themselves. We want to seal Vault and take care of all that stuff. All right, so we have different options for seal and unseal. We have the default, which is kind of key sharding using Shamir's secret sharing algorithm. We have cloud auto unseal. Now, this is taking advantage of something like AWS KMS or Azure Key Vault or things like that that we can use to protect our master key. And then we also have transit auto unseal. So we can actually use another Vault cluster to unseal all these other clusters. So we're going to talk about each one of these. Unsealing with key shards here. So again, if we go back to our original picture, we have our storage backend, we have our encryption key, which protects our data, we have our master key that protects our encryption key, but how do we protect our master key? What we do to protect our master key using key shards is we actually use Shamir's secret sharing algorithm, let's say that 5 times fast, to break up the master key in what we call key shards, or they're also referred to as unseal keys. Now, the idea behind these unseal keys is that what we're going to do is we're going to pick 5 trusted employees in our organization. Maybe they're security, maybe they're management, maybe they're just 5 folks that are on the Vault team. But the idea is that we're going to give these key shards to each one of these employees. And the idea is that now we don't have a single person in our organization that has the so-called all the keys to the kingdom. Each individual person has an individual key, right? We don't have one person that has access to all the keys. Now, what happens is that when we want to unseal Vault, we need a threshold of keys. So by default, Vault is going to create 5 keys for us, and we have a threshold of 3, meaning in order to unseal Vault, we need at least 3 of those 5 keys. Doesn't matter which 3, could be any combination, but we need at least 3. And what Vault can do is it can take 3 of those keys, it can use that to reconstruct our master key, and again, use the master key to decrypt the encryption key, and use the encryption key to decrypt the data. All right, so let's see what this looks like to unseal. So say, hey, we want to run a Vault status on our Vault, right? It's currently sealed. So we're going to go into our terminal, say Vault status. Cool, you know what? Vault shows us that the seal type is currently Shamir, meaning that we're going to use keys. It currently says, hey, Vault is sealed right now, so we can't do anything with Vault. It's saying that, hey, we have 5 keys. We have 5 total shares, key shards, unsealed keys, whatever you want to call them, 5 shares here. And we're saying we need a threshold of 3 of those keys in order to unseal Vault. And finally, it shows like, hey, if you're going to unseal Vault, the unseal progress right now, like Vault has received no keys, right? I have 0 of 3 keys towards the unseal progress. So let's go through the process of unsealing Vault through the magic of PowerPoint. So what we're going to do is we're going to say, hey, I need your key. So she's going to provide her key. Now, if you run Vault status again, you can see we have the same thing, except for now our unseal progress is 1 of 3. So we've got 1 of our keys. We provide another key. Now we have the unseal progress of 2 out of 3. And finally, our third key is presented. Vault has enough keys in order to reconstruct the master key, and Vault is unsealed. So you can still see if you walk through the Vault status over here, seal type Shamir. Now Vault is not sealed, right? It says false. We have total shares of 5, we have 3, and now it shows us additional information about Vault. So we're running version 1.7, storage type is console, the cluster name is Vault-cluster. We have the cluster ID, and we have determined like the HA is enabled. So let's look at some points here around key shards. So this is default option for unsealing, no configuration needed for key shards, right? So you don't have to put anything in the configuration file. It'll just happen for you. The idea behind unsealing with key shards is no single person should have access to all those key shards. Ideally, each key shard should be stored by a different employee. Now, when you're initializing Vault, you can request the individual key shards to be encrypted with PGP keys. So if we go back to our 5 employees, before we run an initialization, we would have those users provide us with their public PGP key, and we can provide that to Vault and say, hey, Vault, I want to initialize you, but when you provide me the keys, go ahead and encrypt the 5 keys with these 5 different PGP public keys. And what that does is a person who is initializing Vault, they actually never see all 5 keys in an unencrypted manner. So again, even the person unsealing vaults or initializing vaults, they still don't get the keys to the kingdom because they are encrypted with everybody else's PGP keys. Now, when unsealing vaults, you will need an equal number of employees to provide their key, which is equal to the threshold. So you saw before we had 5 keys, we had a threshold of 3. That means if you are using key shards, you need 3 of those people to provide their key to unseal vaults. Now, the downside to that is that, if you're restarting vaults in the middle of the night, maybe you got to wake up 3 people in the middle of the night, right? It may not be a good idea for your organization. So, we'll talk about that. Key shards should not be stored online. So you should always kind of store them offline so they're not accessible by automated means. And they should be highly protected and ideally stored in an encrypted fashion. So let's take a look to see what this looks like in a demonstration here. Unsealing with key shards here. So again, if we go back to our original picture, we have our storage backend, we have our encryption key, which protects our data. We have our master key that protects our encryption key. But how do we protect our master key? What we do to protect our master key using key shards is we actually use Shamir's secret sharing algorithm, I'll say that 5 times fast, to break up the master key in what we call key shards, or they're also referred to as unseal keys. Now, the idea behind these unseal keys is that what we're going to do is we're going to pick 5 trusted employees in our organization. Maybe they're security, maybe they're management, maybe they're just 5 folks that are on the vault team. But the idea is that we're going to give these key shards to each one of these employees. And the idea is that now we don't have a single person in our organization that has the so-called all the keys to the kingdom. Each individual person has an individual key, right? We don't have one person that has access to all the keys. Now, what happens is that when we want to unseal Vault, we need a threshold of keys. So by default, Vault is going to create 5 keys for us, and we have a threshold of 3, meaning in order to unseal Vault, we need at least 3 of those 5 keys. Doesn't matter which 3, could be any combination, but we need at least 3. And what Vault can do is it can take 3 of those keys, it can use that to reconstruct our master key, and again, use the master key to decrypt the encryption key, and use the encryption key to decrypt the data. All right, so let's see what this looks like to unseal. So say, hey, we want to run a vault status on our vault, right? It's currently sealed. So we're going to go into our terminal, say vault status. Cool, you know what? Vault shows us that the seal type is currently Shamir, meaning that we're going to use keys. It currently says, hey, vault is sealed right now, so we can't do anything with vault. It's saying that, hey, we have 5 keys. We have 5 total shares, key shards, unsealed keys, whatever you want to call them, 5 shares here. And we're saying we need a threshold of 3 of those keys in order to unseal Vault. And finally, it shows like, hey, if you're going to unseal Vault, the unseal progress right now, like Vault has received no keys, right? I have 0 of 3 keys towards the unseal progress. So let's go through the process of unsealing Vault through the magic of PowerPoint. So what we're going to do is we're going to say, hey, I need your key. So she's going to provide her key. Now, if you run vault status again, you can see we have the same thing, except for now our unseal progress is 1 of 3. So we've got 1 of our keys. We provide another key. Now we have the unseal progress of 2 out of 3. And finally, our third key is presented. Vault has enough keys in order to reconstruct the master key, and Vault is unsealed. So you can still see if you walk through the Vault status over here, seal type Shamir. Now Vault is not sealed, right? It says false. We have total shares of 5, we have 3, and now it shows us additional information about Vault. So we're running version 1.7, storage type is console, the cluster name is vault-cluster. We have the cluster ID, and we have determined like the HA is enabled. So let's look at some points here around key shards. So this is the default option for unsealing, no configuration needed for key shards, right? So you don't have to put anything in the configuration file. It'll just happen for you. The idea behind unsealing with key shards is no single person should have access to all those key shards. Ideally, each key shard should be stored by a different employee. Now, when you're initializing Vault, you can request the individual key shards to be encrypted with PGP keys. So if we go back to our 5 employees, before we run an initialization, We would have those users provide us with their public PGP key, and we can provide that to Vault and say, hey, Vault, I want to initialize you, but when you provide me the keys, go ahead and encrypt the 5 keys with these 5 different PGP public keys. And what that does is a person who is initializing Vault, they actually never see all 5 keys in an unencrypted manner. So again, even the person unsealing Vault or initializing Vault, they still don't get the keys to the kingdom because they are encrypted with everybody else's PGP keys. Now, when unsealing Vault, you will need an equal number of employees to provide their key, which is equal to the threshold. So you saw before we had 5 keys, we had a threshold of 3. That means if you are using key shards, you need 3 of those people to provide their key to unseal Vault. Now, the downside to that is that, if you're restarting vaults in the middle of the night, maybe you got to wake up 3 people in the middle of the night, right? It may not be a good idea for your organization. So, we'll talk about that. Key shards should not be stored online. So you should always kind of store them offline so they're not accessible by automated means. And they should be highly protected and ideally stored in an encrypted fashion. So let's take a look to see what this looks like in a demonstration here. Hey everyone, welcome to this lab where we are going to learn how to unseal Vault using the default mechanism of unseal keys. All right, so on the screen here, I have an SSH session open to a node running out in AWS, and I've got the Vault binary and a simple configuration on it. So what we're going to do is take a quick look at the Vault status here. So do Vault status. You can see that the seal type is Shamir, and you can see that this Vault cluster or node has not yet been initialized, which also means that is not been unsealed. So let's take a quick look at our configuration file just to see what we need to unseal this with our unseal keys. So if I do a cat etc vault d and then vault HCL, you can see that, hey, I don't have anything in this configuration file in regards to a seal mechanism. So we learned in the lecture that if you want to use the unseal keys, you don't have to put anything in the configuration file because it is the default mechanism for unsealing Vault. So let's clear our screen here. And now, again, we can run Vault status to show where we're at. And all we have to do to unseal and initialize Vault is we're going to say Vault operator init. So this is going to initialize our Vault cluster or our Vault node here. So once this happens, we will get the unseal keys, which are right here, and we will get the initial root token. Now, remember, this is the only way that we can authenticate to Vault at this point. Remember, root token is the only method that we can log in because tokens are the only auth method that are available when you first create your Vault cluster. All right, so now that we have our unseal keys, now we can look at Vault status again. And we can see that, yeah, our cluster or node is initialized, but it's still sealed. So let's unseal this node. So in order to do that, we're going to need our unseal keys that we just got up here. So what we're going to do is we're going to say vault operator unseal, and we're going to press enter, and it's asking for one of these unseal keys. Now again, it doesn't matter which one you grab. So I'm going to grab key number 4 here, copy that, provide it, and hit enter. All right, check that out. Now we have unseal progress of 1 of 3, and we're showing that, hey, we need at least 3 keys out of the 5 keys in order to unseal Vault. So to continue on with unsealing Vault, I'm just going to hit up and say Vault operator unseal again, hit enter. I'm going to scroll back up here, and I don't know, I'm going to grab number 1 here. Again, it doesn't matter which order or anything. I'm going to right click and paste that in, hit enter, and now we are unseal progress 2 of 3. All right, so we do that one more time. Vault operator unseal. This time I'm going to grab key number 5, paste that in, and hit enter. So check that out. Now we have initialized Vault. We did that. That's where we got our unseal keys and our root token. But now you can see that we are no longer sealed, which means that this cluster or node is officially unsealed, and we can start interacting with Vault at this point. You can also see that once we unsealed, we actually got a bunch of additional information. So before we kind of stopped at storage type, And now we have cluster name, cluster ID, HA, all those kind of things. So if we wanted to, we could start interacting with Vault. So for example, we could say Vault secrets list. We can see, oh, we got to authenticate. It's my fault. We just talked about that, right? So grab the root token here, and then we'll do Vault login, and we'll provide the token here. Cool. Now we are logged in with the root token. You can see that the token policy is roots, and you can see that it never expires. It's got an infinity symbol right here. So again, now we are logged in to Vault, so we could say Vault secrets list, and we don't have much, right? We have the default stuff, cubbyhole, identity, and the backend sys. Anyway, so that's how you would unseal Vault using our unsealed keys. And of course, we took it one step forward and we logged in with our root token, and then we were able to start running Vault commands. All right, so now we understand more about unsealing the manual way. And for a long time, actually for Vault, that was the only way. But after a while, a lot of people start complaining like, you know what? I don't like this manual process of unsealing Vault. I don't like to get 3 people up in the middle of the night when we have to do maintenance on the Vault nodes to install patches or something like that. So HashiCorp came up with what's called auto unseal. So again, we'll walk through our picture here. We got our Vault data, encryption key protects our data, master key protects our encryption key. But instead of breaking up our master key into multiple shards, what we're going to do is we're going to use a cloud service to protect our master key. And what I mean by that is something like Azure, AWS, Google, AliCloud. They all have kind of key management services that we can go into. We can create a key and we can say, hey, you know what, Vault? I want to use this key on this public cloud platform in order to encrypt and decrypt my master key. Now, what happens is the master key, in this case, actually gets stored on the storage backend. We talked about that before under core master, but it is encrypted by our cloud KMS key. So if we go into Azure and we create a key in key